Hello and welcome to another video, this time on question 5 from the 2020 mechanics paper, and it's a projectiles question. Okay, let's have a go at it. So what do we got here? We've got, the diagrams in projectiles questions. It's dangerous not to read this blurb, but often it's all on the diagram. But don't be me and miss out reading some relevant information. Anyway, so let's have a good quick read through it. U is the speed of projection, obviously, 25 meters above the ground. Ball is projected 45 degrees to the horizon. Ball hits the ground at point A. All right, well, that's useful to know. So it's going like that. Where that is 100 meters. So that's really important to know. Show that U is 28. So, okay, right. Well, and this is going to be most of the marks for this question by the look of it. Well, what I would do personally here is I'd set up my vectors. U is going to be equal to U cos 45 and U sine 45. You always have A is 0 minus G. Now in this one you've also got S, because S is actually negative 25 for the Y component and 100 for the X component, yeah? And if you're in doubt with what else to write down, I normally put down on this T equals T. In other words, and then I could set up two equations with this with two unknowns, because I can use S equals UT plus a half AT squared. Oh, I don't like doing that, sorry. I don't like it when the line almost looks like it's going above the A. So S equals UT plus half AT squared. But if I use it on the horizontal components, then I've just got 100 equals UT cos 45, and then I'm going to have 0 for the last bit, because a half times 0 is 0. Do you see what I mean? So I can ignore that. Now, cos 45 is 1 over root 2, so you get UT over root 2, and so if you did want to eliminate t, which I kind of do, you could have t equals 100 root 2 over u. Yeah. Now the reason I'm doing that is because if I now use it with that was with obviously the horizontal components, but I quite like to do it with the vertical components now, and so I'm going to have minus 25 equals ut sine 45, which is root 2, once again, 1 over root 2 should I say, minus g over 2 t squared, yeah? Now, if I now run this through, I'll have a quadratic in u. Let me show you what I mean. I'm going to have that u is going to cancel with that u, and then that's going to be a root 2 times root 2. So that's actually going to take the value of 200 in the end after you've worked everything through, just because I'm swapping t for that. The u's cancel, then you've got 100 root 2. Oh, sorry, I'm wrong here, because that's actually 1 over root 2. Try not to be too slapdash. It's because I'm doing it all in my head. You may prefer to work a little bit more carefully and have a few more lines of working, and there's nothing wrong with that. There's no shame in that. Working is there to help, and as you can see, I almost made a mistake there just because I wanted to sort of skirt around the working. But u times by 1 over u, they're going to cancel. Then you're going to have 100 root 2 over root 2, and that's 100. Yeah, and then we've got minus g over 2, and I might as well get rid of the t because I want to show u is 28. So let's have this as 100 root 2 over u, and we're squaring that, yeah? So if we just rearrange this a bit, we're going to have g over 2 multiplied by, okay, that's going to be 100 squared, which is 10,000, times by 2 over u squared equals 125, yeah? And now if we just rearrange this, the 2's are going to cancel, and we're going to have u squared equals 10,000 g over, because I'm timesing this over here and dividing it under there, 125. And so let's just check this on my calculator and check it works out. At least it's one of those ones where we know the answer. 10,000 times 9.8 divided by 125, and then square root the answer. And sure enough, u is 28 as required, which is nice. Yeah, it's quite a tricky one, that one. Didn't feel really straightforward, did it? Okay, find the greatest height of the ball. Is that above the horizon? Above the ground, NA. Yeah, above the horizon. So we're trying to find the greatest height here. That always occurs when the vertical component is 0. Yeah. So this one doesn't seem too bad, this part of the question anyway. We're going to have very similar setups. At least we now know that this is 28 cos 45 and 28 sine 45. A is still 0 minus g. That's always an easy one. We're looking for, well, we know v. I always say we might not know the Vx component, but actually we do. It's going to be 28t cos 45, but that's just because of how our V equals U plus AT works, yeah? In fact, it's just going to be 28 cos 45, what we're talking about t, if you're looking for the velocity. Okay, and then Vy, well, that's going to be 0. And now what are we trying to find here? I've forgotten. The greatest height. So you're looking for S, yeah? But remember that when you find S here, on these questions, I'm at pains to point out your origin is always where you start, yeah. And so it's going to tell you how high above, how much high you were, how high you were above the origin, and you're going to have to add on 25 if you find the greatest height above AN. So we will need to add on 25 at the end. Okay, so let's do it. By the look of it, V squared is U squared plus 2AS looks good. And so you're going to have 0 equals, that's 28 over root 2. So after you square it, you get 784 over 2. I'll work out what that is in a second. Minus 2gs. And so s is going to be equal to, and I can just do it on my calculator now, 784 divided by 2, 392 divided by 2g. And that equals a lovely satisfying answer of 20, and so the height above AN is 45 meters, or NA they were calling it. It seems like a weird thing to call it. Okay, and that's that one done. Now let's have a look at what they've got in the next part of the question. 1 second, let me just move this over. I'm not great on this whiteboard. Okay, in a refinement to the model of the motion of the ball from A to O to A, sorry, the effect of air resistance is included. They're actually going to ask you how air resistance affects answers, which is good. I always think it's important that you actually talk about what air resistance would do. The refined model is used to find a new value of U. How would this compare to the old value of U? Well, if you've got resistance, you're going to have to fire the thing faster to get to the same distance, if you see what I mean. So you would need to increase. And that's just because we've suddenly got something resisting the motion of the ball. So we're going to have to fire it faster for it to clear 100 meters again. So you would need to increase. State one further refinement to the model you make to make it more realistic. You could take into account spin of the ball, or you could take into account the dimension of the particle, or all sorts of other answers. Do have a look at the mark schemes for what the kind of things are that they accept. But I believe it's take into account spin of the ball, or the dimension of the ball. Yes, so it's not treated as a particle. What else do they allow? I've got the mark scheme open in another window. They allow spin of the ball, wind effects, use a more accurate value of G. They're not model it as a particle. You could take into account the shape of the ball. Lots of other answers possible there. Okay, I hope that was useful. Keep up the good work, and yeah, basically come and see me if you're stuck. Bye bye.